Imagine you are standing on the surface of the moon, not watching it from Earth, not reading about it in a textbook. You are there. Your boots are pressing into ancient gray dust that hasn't been touched in 4 billion years. Above you, no clouds, no sky, no atmosphere, just an infinite black void, and hanging inside that void, a pale blue circle. That's Earth. That's everyone you've ever known, every city, every ocean, every person who has ever lived, and it is 384,000 kilometers away. You are more isolated than any human being in history, more alone than anyone has ever been, and in approximately 72 hours, if everything goes perfectly, if not a single system fails, if not a single calculation is wrong, you might make it back. But this is Artemis 3, and nothing about this mission is guaranteed. The dream that almost wasn't for 50 years, humanity stayed home. After Apollo 17 lifted off the lunar surface in December 1972, we simply stopped. No one went back. The moon hung in the sky every night, silent and waiting, and we looked up at it from Earth and told ourselves we'd return soon. Decades passed. Generations grew up never seeing a human footprint pressed into that gray dust in real time. Then came Artemis, NASA's promise to return, not just to visit, but to stay, to build, to use the moon as a launch pad for Mars, for the outer solar system, for the stars themselves. Artemis 3 would be the crown jewel, the first crewed lunar landing since Apollo, the first woman and first person of color to stand on the moon. It looked like the beginning of a new era, but here's the problem. It might also be the end of one. The weight of everything that can go wrong. Let's talk about what it actually takes to survive on the moon, because most people imagine it's like camping somewhere cold and remote. It is not. The moon is not just inhospitable, it is one of the most lethal environments a human body can be placed in. Start with the temperature. On the sunlit surface, the temperature reaches 127 degrees Celsius, hot enough to boil water, hot enough to cook you through your suit if the thermal systems fail even slightly. Then the sun sets, and within hours, the temperature plunges to negative 173 degrees. That's a swing of 300 degrees between day and night. Your suit, your equipment, your habitat, all of it must endure that transition without cracking, without failing, without a single seal break. If it breaks, you have minutes. But it gets worse. The moon has no magnetic field, no atmosphere, no protection of any kind from the sun's radiation. On Earth, you are shielded by thousands of kilometers of air and a magnetic bubble that deflects the most lethal particles. On the moon, there is nothing between you and a solar flare. If the sun erupts at the wrong moment and the sun does not give warnings, astronauts on the lunar surface would be exposed to radiation doses that could cause acute radiation sickness within hours, organ failure within days. NASA has contingency plans for this, shelters, warnings, abort protocols, but contingency plans are written on Earth. On the moon, the margin for error is almost nothing, and this is where things change. The machine that has never been tested. Artemis 3 depends on a vehicle that has never landed humans anywhere. SpaceX's Starship human landing system, a towering stainless steel rocket unlike anything ever built, is the only craft designed to take the Artemis crew from lunar orbit down to the surface and back. It is enormous, it is revolutionary, and as of now, it has never completed a full lunar landing simulation with humans on board in actual lunar conditions. This is not a criticism, it is a fact. Every spacecraft that has ever carried humans was tested, failed, was redesigned, failed again, and eventually, after years of incremental refinement, was trusted. The Apollo lunar module went through relentless testing before Neil Armstrong climbed inside. Artemis 3 is operating on a compressed timeline, under political pressure, under budget constraints that have already delayed the mission multiple times, and the Starship has to do something extraordinary. It has to descend through zero atmosphere, meaning no air resistance to slow it down, pure rocket thrust the entire way, and land precisely on a surface we have never fully mapped at the resolution required for a safe touchdown. One miscalculation, one thruster that fires 0.3 seconds too long, one sensor that reads the terrain wrong, and the last moon mission ends before it begins. But that's not even the worst part, the South Pole and the darkness that never ends. Artemis 3 isn't landing just anywhere on the moon. The mission targets the lunar South Pole, a region of jagged crater rims, permanent shadows, and terrain that has never seen direct sunlight in billions of years. The reason is scientifically extraordinary. Trapped in those frozen shadows is water ice, real water, the kind that could be converted into rocket fuel, into drinking water, into oxygen. If humanity is ever going to use the moon as a true base, the South Pole is where that future begins. But the South Pole is also one of the most treacherous environments on the moon. The terrain is uneven, ancient, and poorly understood. Communication with Earth is complicated by the geography. The permanently shadowed craters, and astronauts may need to venture near them, are so dark that even the most advanced sensors struggle to map what's inside. The temperatures in those shadows are the coldest measured anywhere in the solar system. Negative negative 250 degrees Celsius, colder than Pluto. If an astronaut slips, if a suit is compromised, if the rover fails at the edge of one of those craters, there is no rescue mission coming, not in time, not from 384,000 kilometers away. But here's the problem. The danger isn't only physical. The politics of the last mission. Artemis 3 exists inside a fragile political ecosystem that most people never think about. The Artemis program costs billions of dollars per year. It has survived presidential transitions, budget fights, congressional skepticism, and internal NASA restructuring. It has already been delayed. It has already been scaled back. And it exists in a world where other nations, China in particular, are accelerating their own lunar ambitions with alarming speed. If Artemis 3 launches and something goes wrong, not catastrophically, not a loss of crew, but simply a failed landing, a mission abort, a highly publicized near miss, the political will to fund another attempt may simply evaporate. Public appetite for expensive, dangerous space exploration has always been fragile. Apollo ended not because we ran out of rockets, but because the public grew tired of it. Congress pulled the funding. 3 planned missions were canceled overnight. It can happen again. And if it does, if Artemis 3 stumbles and the program collapses under the weight of political pressure and public doubt, we may be looking at another 50-year gap, another half-century of looking at the moon from Earth, telling ourselves we'll go back soon. And this time, we may not have 50 years to waste. The clock that's already running here is the existential truth underneath all of this. Humanity is not permanent. Earth is not permanent. The systems that sustain human life on this planet, the climate, the biosphere, the geological stability that we have always taken for granted, are under pressure in ways that no generation before us has ever faced. The argument for becoming a multi-planetary species is not science fiction anymore. It is increasingly an argument about survival. The moon is the first step, not the destination. The first step. Artemis 3 represents the moment humanity decides, in practice rather than in theory, whether we are actually going to take that step, whether we are the kind of species that pushes forward into the unknown, or the kind that builds cathedrals to past achievements and never leaves home. But it gets worse. Every year of delay is a year that China advances its own crude lunar program, a year that the geopolitical landscape shifts, a year that the technology funding flows somewhere else, a year that the engineers who built Artemis grow older, retire, disappear, taking institutional knowledge with them the way it disappeared after Apollo. The window is not infinite. It never was. The last footprint. There is a photograph from Apollo 17 that most people have never looked at closely. It shows Harrison Schmidt's boot print in the lunar soil, the last human footprint ever pressed into the surface of another world. It has been sitting there perfectly preserved for over 50 years. No wind to disturb it, no rain, no decay, just a boot print in ancient dust, waiting. It has been waiting longer than some countries have existed. If Artemis 3 fails, politically, technically, financially, that boot print may wait another 50 years or longer. It may wait until the program is revived by a generation that hasn't been born yet, under conditions we can't predict, for reasons we can't yet imagine. Or it may never be joined by another. The universe doesn't care about our timelines. It doesn't care about our budgets or our politics or our courage. It was here before us, and it will be here long after us, indifferent and vast and silent. Artemis 3 is humanity's attempt to say, we are still trying. We are still moving forward. We have not given up. But the moon has seen empires rise and collapse before. It has watched species go extinct, and it will still be there, hanging in the black, long after the last human being looks up at it for the very last time. The question is whether we make it back before that moment comes, or whether the next footprint on the moon is made by someone or something that isn't us at all.